Hey guys, we are continuing our Jam Achiever series and this is lecture number 3. And we are going to discuss about the topic hydrogeology and this is part 3 video. And here are some of the reference book for your preparation. Welcome to my channel Success Guru and myself Panchanadam, and let's get into the heading. So far what we had seen is some of hydraulic properties, that is storativity, transmissivity, then these properties along with the classification of rocks, right? So now we are going to discuss about the Darcy's law, which actually governs the movement of groundwater. Okay, so this law that governs the behavior of groundwater flow in a saturated material is that formulated empirically by French municipal engineer Henry Darcy in the 1856. So he is the first one to calculate the amount of water flow in a fully saturated aquifer. Okay, or any medium, we can call it like that. So Darcy studied the flow of water through porous material contains in a column and found that the total flow Q is proportional to difference in water level, that is H1 minus H2. The cross-sectional area of flow, that is A, inversely proportional to the column length L. So this is what his apparatus. So what he is doing is he is sending the water with high pressure here, right? So here is the medium which you are going to cross check the porosity. Okay, and here is the cross sectional area of that medium, and here is the length of that medium. Okay, and there are two different tubes to show the difference in head in two different location. Okay, so when you pass the water from here to there, the water will move slowly from here, and it has to move all the spores and voids in this rock, and it has to pass from here and comes out like this way. Okay, so this is the total flow, or you can call it as Q simply. Okay, so this amount is proportional to the first thing is the difference in water level. So what is the difference in water level in the entrance and in the exit? You can keep it that way. So this is H1 and this one is H2. So H1 minus H2 will give you the difference in water level and the cross sectional area. Okay, so as you can understand that if the difference in head will be high, the outflow will be very high, right? As it is directly proportional. And if the area is higher, that is if it is quite bigger than this, then the outflow will be higher, right? So this is proportional to the total flow and it is inversely proportional to the column length. So this is the column length L. So if you are having higher column length, then the flow will be comparatively less or slower. You can keep it in that way. So this is what Darcy's explanation about this hydraulic conductivity, or simply we can call it as a movement of water from one portion to other through a porous medium. Okay, so he derived the formula Q is equal to Ka H1 minus H2 by L, where you can consider K as the proportionality constant and A, as you mentioned earlier, this is the area of cross section, and H1 minus H2 will give you the head difference, and L is the length of this porous material. Okay, or you can simply write it in this way, that Q is equal to minus Ka dH by dL. So where dH by dL represents the hydraulic gradient. So you can compare it in this way, height difference by length as hydraulic gradient with a negative sign in the front that indicates the flow in the direction of decreasing hydraulic head. So as you can see here, the hydraulic head is lesser in this side, that is in the upper side. So the water will flow from bottom to top. If it is vice versa, then the water will move from top to bottom. So that is what they are trying to say here. The negative indicates that the flow in the direction of decreasing hydraulic head. So wherever there is hydraulic head falling, there will be movement of water, and this is the reason why we are getting water when you are pumping out water from a well or a borehole, as there is a loss in hydraulic head, right? So the water from the surrounding rock will move towards this portion, which is expressed or explained by Darcy from this formula. Is that clear? Okay, but remember, Darcy's law is valid for laminar flow. So if you are discussing about the flow of water, there are two types of flow. One is laminar flow and other is the turbulent flow. So if the velocity of water according to Reynolds number is less than 1, it is called as a laminar flow, and if it is higher than 1, then it is called as a turbulent flow. So this law is applicable only for the flow of the liquid that should be less than 1, that is it should be a laminar flow. So what is Reynolds number formula? Reynolds number formula is equal to rho Vd by nu. Okay, So rho is the density of water and nu is the dynamic viscosity of the water, or you can consider density of a fluid. In that way you can also consider it, no problem. So here density of the water and density of dynamic viscosity of the water, and d is the mean grain size of the aquifer, what we are dealing with here, or a medium, and v is the velocity of the liquid. So if the result of this calculation is less than 1, then it is called as a laminar flow, and if it is higher than 1, then it is called as a turbulent flow. Okay, and if the value is less than 1, then we can apply this Darcy's law to such a type of flow, and if it is higher than 1, then we can't use this formula in any of such a rock which is having higher Reynolds number. Okay, so this formula is applicable for groundwater. In that also it should be a laminar flow. So you will be having where you are getting turbulent flow in groundwater, right? So when you are dealing with limestone caverns, as you might study about the caves, stalactites, stalagmite, all such features in limestone, right? So the water flow in those region can also be called as the groundwater, but the flow there will be more than one. So this formula or this property or this derivation is not applicable for such a kind of flow. Okay, is that clear? Okay. So now we are going to see other terms in groundwater or hydrogeology and other relationship between these terms. So the next term is the hydraulic conductivity. Remember, you have studied about the permeability, right? It is the ability of a rock to transmit water. This is somewhat similar to that, but the main difference is the hydraulic conductivity is a measure of material ability to transmit water through its porous space or fracture. It depends on both properties of material and the property of the fluid, such as viscosity and density. Okay, so the difference is here. In permeability, what we are dealing is we are mainly concerned with the medium which is actually passing the water or which is actually transmitting the water. But here hydraulic conductivity is also depend on the water's other physical or chemical properties like viscosity, density and other things, right? Fluidity, all such things, right? So this is the actual amount of movement of any liquid or water in a rock, whereas the permeability is the maximum amount of water or any liquid that can pass through at a fixed velocity, right? So that is the higher range and this is the actual range. We can keep it in that way. Is that clear? Okay, the next term is the transmissibility. The transmissibility is the flow capacity of an aquifer per unit width under unit hydraulic gradient and is equal to the product of permeability times the saturated thickness of the aquifer. So here is the next term which deals with the unit volume and the unit area, right? So it is like the transmissibility is the flow capacity of an aquifer per unit width under unit hydraulic gradient. So here it is a basic derivation or a basic formula to explain the transmissibility, and it is also depends on the type of aquifer. If you are concerning about the confined aquifer, the formula for transmissibility is equal T is equal to Kb, where K is the constant as you know and B is the independent of piezometric surface, that is the thickness of that aquifer. Okay, but if you are dealing with the unconfined aquifer, the water table aquifer, then T is equal to KH, where H is the saturation thickness. As the water table drops, H decreases and the transmissibility is reduced. Thus the transmissibility of an unconfined aquifer depends on the depth of the groundwater table. So remember that if you are dealing with the confined aquifer, the transmissibility will be fixed, right? So the B is the thickness of that aquifer and K is the hydraulic conductivity, right? Whereas in terms of unconfined aquifer, the transmissibility is actually changing when there is a drop in water level, right? As K indicates the saturation thickness. If you take out some water, the thickness will reduce, right? As it is, the value will of the K H also will reduce and the transmissibility value also reduce. So the transmissibility is depend on the depth of the groundwater table. Is that clear? Okay. So the next one is the relation between volume of voids, mass, density and volume. So if you want to calculate the volume of a solid or the grains in a rock, then volume of solid is equal to mass of the solid by density of the solid. So when there is a question about the volume of solid. If you have two derivatives like mass of solid and the density of solid, you can use these two to find out the volume of solid, or you can also use the average density of the particle. So in the question, if they are given the density of solid, you can use it directly, or in the question, if they are giving the average density of the particle, then also you can use that thing here. So the volume of the solid is equal to mass of the solid by density of the solid, or average density of the particle. This is whatever it is in the given in the question. Then if you want to calculate the voids from the above equation, then you can use the volume of voids is equal to total volume which you had find from the above equation minus total volume of the solid, whatever it is present there. So this gives the volume of void. So this is what the relation between mass, density and volume, especially in terms of a porous medium, which we are going to use for our upcoming calculations. The next one is the specific yield. As I mentioned earlier, specific yield is equal to porosity minus specific retention, or in the previous class I mentioned that porosity is equal to specific yield plus specific retention, right? So you can rewrite this equation as you wish to find the unknown one from the known two of the given data. Is that clear? The next one is the calculating change in the storage or storativity, what you call. So it can be calculated by the area of the aquifer into drop in the water level multiplied by specific yield. So if you have the area of the aquifer, cross section area, right, into the drop in water table level and also the specific yield of an aquifer, you can simply calculate the change in the storage. So there are questions which has been asked for calculating the change in the storage. That's why I'm sharing these formulas. Then the next one is the relation between porosity. Porosity N is equal to E by 1 plus E, where E stands for void ratio. Or you can simply calculate E is equal to volume of voids by volume of solid. Okay. So this is the relation between porosity and void ratio. So the void ratio is equal to volume of void by volume of solid, or porosity is equal to void ratio by 1 plus void ratio. So you can use any of this formula to find out the other missing term. The next one is the calculating cross-sectional area of a cylindrical sample. So when you are dealing with hydrology, many a time you come across the sample with a cylindrical in shape, right? So if you want to find out the cross-sectional area, you can simply find area is equal to pi r square, which is the formula for a circle, right? So if they give the diameter of the cylinder, you can divide it by 2, then you can find the radius and you can simply apply this formula there, which can be used to find out Darcy's flow rate or anything in this way. The next one is the calculation of flow rate Q, which is equal to V by T, where V is the volume of water collected by time. So this will give the flow rate. Okay. The last one is coefficient of permeability, that is K, which is equal to Q by I, that is the discharge per unit area by hydraulic gradient. So coefficient of permeability K we had discussed in ERS side also, where K we had discussed, right, which is equal to discharge per unit area by hydraulic gradient. So these are some of the formulas and relation between specific terms which we can use to solve the previous JAM questions. So probably these are the maximum amount of formulas which I had found. If I found anything else, I will make the fourth part if possible in the hydrology, or you will jump to the next heading. And if you have any doubt, mention in the comment section, we will try to solve it, right? And here are some of the questions from JAM 2005 to 2024. And actually here it is 5 and here it is 5, 10 and there is 2. So there are 12 questions from the above mentioned slides. So just go through these questions and try to solve these questions. I do share these questions in my blog and with the key also, as some of you were asking for the key. I had shared the questions along with the key for the previous videos also. So you can try cross check that blog. I had shared the link in the description. Okay. And I had shout out by my students Solaimal and Mutumari. Thanks for them. And thanks for watching. Have a great day.